Use the graph of f of x equals the square root of x minus 2 to find f of 1 and f of 4, for which values of x is f of x equal to 0. Then find the domain and range of f. Let's start by finding f of 1 and f of 4. F of 1 just refers to the function value when x equals 1. When x equals 1, we look down to see where the function is, and we can see that there is a point on the graph that has an x-coordinate of 1, and if we look at the y-coordinate, it has a y-coordinate of -1, so we know that f of 1 is equal to -1. Similarly, to find f of 4, we look for 4 on the x-axis, and we look to see what point on the graph has an x-coordinate of 4, and we can see it's right here. This is actually the intercept, and so the y value here is 0. That means f of 4 equals 0. Next, we want to figure out for which values of x is f of x equal to 0. To do that, on the y-axis, we find 0, and then we look to the left and the right to see if there are any points on our graph that have a y-coordinate of 0. We can see that there's one point here in this case, and that has an x-coordinate of 4, so we know that f of x equals 0 when x equals 4. In this case, there's only one value of x that has a function value of 0. In the previous examples, there were two values of x that had a function value of 0. And in a situation like this, there can be one value, there can be two values, there can be 10 values, there could be no values. So really, there are multiple options for how something like this can play out. Now, let's move on to look at the domain and range. Remember, the domain is the set of possible x values for our function. So what we do is we take points on our graph and we project them to the x-axis, and we look to see which parts of the x-axis are included on these projections. And we can see clearly that all of the positive numbers are included here, and then also 0 is, because the point 0, -2 is on our graph, and that corresponds to an x-coordinate of 0. And none of the negative values are included because our graph does not go to the left of the y-axis. So our domain is only going to include positive numbers and 0, and the way that we can express that is by saying x has to be greater than or equal to 0. So the domain is the set of numbers x such that x is greater than or equal to 0. Now we can look at the range. For the range, we're looking at the y values that correspond to our graph. So we can take points on our graph and we can project them onto the y-axis. We can see we've got some negative and some positive values here. And as of right now, we're seeing positive values that go close to 2, so we might ask ourselves if that's going to be where they stop, if they don't keep going. However, we know that this graph is going to continue going on because of this arrowhead. And I'm going to cheat a little bit here because what we know about this graph, this function, the square root of x plus 2, is that as x gets larger, our function is going to continue increasing and increasing. This is kind of a really ugly sketch, but this is going to keep going up and up and up. And we might have to go very far to the right, but this function is going to continue increasing, and we are going to continue to have y values getting larger and larger. So in this case, if we look to see where on the y-axis our values go, well, certainly we have all the positive numbers. We also have some negative numbers, and we stop at -2. That's as far down as our graph goes. We don't have any points below -2. And so for our range, we can say that y has to be greater than or equal to -2. So our final answer for the range is the set of numbers y such that y is greater than or equal to -2.